NASA's Lunar Trailblazer mission fails. What went wrong on the moon? The conclusion of NASA's Lunar Trailblazer mission has left many feeling disheartened. Officially, the mission came to an end on July 31st, but the journey was far from complete. NASA announced that communication with the satellite was lost shortly after its launch several months earlier, marking a significant setback for the project. The Lunar Trailblazer was part of the IM-2 mission orchestrated by Intuitive Machines, which launched aboard a SpaceX Falcon 9 rocket from Kennedy Space Center on February 26 at 7:16 p.m. Eastern Time. The satellite successfully detached from the rocket approximately 48 minutes post-launch. Communication was established by operators in Pasadena, California at 8:13 p.m. Eastern Time. However, the following day, two-way communication was abruptly severed, and efforts to re-establish contact were unsuccessful. Preliminary data received before the satellite went silent indicated that its solar panels were not correctly oriented towards the sun, leading to a depletion of its batteries. Nikki Fox, the Associate Administrator at NASA Headquarters Science Mission Directorate, expressed, "While it was not the outcome we had hoped for, mission experiences like Lunar Trailblazer help us to learn and reduce the risk for future." Low-cost, small satellites to do innovative science as we prepare for a sustained human presence on the moon. Thank you to the Lunar Trailblazer team for their dedication in working on and learning from this mission through to the end. The Lunar Trailblazer mission was one of several planned for lunar exploration in 2025. Its primary objective was to generate high-resolution maps detailing the presence of water on the moon's surface, including an assessment of the quantity, forms, and historical changes of that water. Let's hope that the upcoming missions yield more favorable results. But here's where it gets controversial. Some experts argue that the challenges faced by the Lunar Trailblazer could have been anticipated and mitigated. What do you think? Should NASA have been better prepared for such technical difficulties? Share your thoughts in the comments. NASA's Lunar Trailblazer mission ends. What went wrong? NASA has officially declared the Lunar Trailblazer moon orbiter as non-operational, marking a significant setback in its mission. The 440-pound, 200-kilogram orbiter, which was launched on February 26, 2025, aboard a SpaceX Falcon 9 rocket, lost communication just a day after its launch. Despite NASA's persistent attempts to re-establish contact over the following months, the agency ultimately conceded defeat last week. Nikki Fox, the Associate Administrator of NASA's Science Mission Directorate, expressed the disappointment in a statement, saying, "Although this was not the result we had hoped for, missions like Lunar Trailblazer provide invaluable lessons that help us mitigate risks for future low-cost small satellites. These experiences are crucial as we prepare for a sustained human presence on the moon." Fox also extended gratitude to the Lunar Trailblazer team for their unwavering commitment throughout the mission. The ambitious $94 million Lunar Trailblazer mission was designed to map the moon's water reserves from orbit. This data would have been instrumental for NASA in understanding the distribution and accessibility of this vital resource, especially in light of upcoming crewed Artemis missions aimed at exploring our lunar neighbor. Unfortunately, the orbiter never had the opportunity to fulfill this critical role. The mission team lost contact with Lunar Trailblazer on February 27th, likely due to the probe's solar panels not being oriented towards the sun as intended, leading to a depletion of its batteries. In a collaborative effort, the team worked tirelessly for months to regain communication, enlisting the help of scientists and organizations from around the globe. Andrew Klesch, the project systems engineer for Lunar Trailblazer at NASA's Jet Propulsion Laboratory, noted, "As Lunar Trailblazer drifted further from the moon, our models indicated that the solar panels might eventually receive more sunlight, potentially allowing the spacecraft's batteries to recharge enough to power on its radio. Klesch emphasized the importance of global collaboration in space exploration, stating, "The support from the international community was crucial in helping us understand the spacecraft's spin, orientation, and trajectory. This collaboration provided us with the best chance to attempt to regain contact." Despite these extensive efforts, the mission was officially concluded on July 31st, as confirmed by NASA officials in their recent statement. In related news, Lunar Trailblazer shared its launch with Athena, the second robotic moon lander developed by Intuitive Machines, a Texas-based company. Athena, which successfully landed near the moon's south pole in March, encountered its own challenges, toppling over shortly after landing and cutting its planned 10-day surface mission short. For those interested in ongoing discussions about space exploration, join our space forums to engage with others about the latest missions and celestial events. If you have any news tips, corrections, or comments, feel free to reach out at community@space.com. Michael Wall, a senior space writer at space.com since 2010, specializes in exoplanets, spaceflight, and military space topics. He has also explored the realm of space art. His book, Out There, which delves into the search for extraterrestrial life, was published on November 13, 2018. With a PhD in evolutionary biology from the University of Sydney and a graduate certificate in science writing from the University of California, Santa Cruz, Wall brings a wealth of knowledge to his writing. You can follow him on Twitter to stay updated on his latest projects. NASA's Lunar Trailblazer mission, a journey cut short. The ambitious Lunar Trailblazer mission, aimed at uncovering the mysteries of water on the moon, has come to an unfortunate end. Launched in February 2025, the spacecraft was designed to provide crucial insights into lunar water. But tragically, communication was lost just 1 day after its launch. This setback has left many in the scientific community reflecting on the challenges of space exploration. On February 26th, the Lunar Trailblazer was launched as part of the IM-2 mission by Intuitive Machines, riding aboard a SpaceX Falcon 9 rocket from the Kennedy Space Center. The spacecraft, constructed by Lockheed Martin Space, successfully detached from the rocket approximately 38 minutes post-launch. However, despite initial success, the mission faced a critical failure when contact was lost the following day, and efforts to re-establish communication proved fruitless. Interestingly, another spacecraft, the Polar Resources Ice Mining Experiment, successfully landed on the moon's surface on March 6th, but its mission was cut short due to an unfortunate positioning issue within a crater, limiting its operational time to just 10 hours instead of the planned 10 days. Nikki Fox, the Associate Administrator at NASA headquarters, expressed the agency's commitment to high-risk, high-reward missions like Lunar Trailblazer, stating, "While it was not the outcome we had hoped for, mission experiences like Lunar Trailblazer help us to learn and reduce the risk for future, low-cost small satellites to do innovative science as we prepare for a sustained human presence on the moon." Initial data indicated that the solar arrays of the Lunar Trailblazer were not correctly aligned with the sun, leading to battery depletion. In a collaborative effort, various organizations worldwide attempted to track the spacecraft's position and listen for its radio signals. Andrew Klesch, the project systems engineer at NASA's Jet Propulsion Laboratory, noted that as the spacecraft drifted further into space, there was a possibility that its solar panels might eventually receive enough sunlight to recharge its batteries and re-establish communication. He emphasized the importance of global collaboration in space exploration, stating, "This gave us the best chance to try to regain contact." Unfortunately, as time passed, The Lunar Trailblazer became too distant, and its signals weakened to the point where recovery was no longer feasible. The mission's high-resolution volatiles and minerals moon mapper imaging spectrometer, designed to detect and map water and minerals, remains a testament to the technological advancements made during this endeavor. Additionally, the Lunar Thermal Mapper instrument, developed by the University of Oxford with funding from the UK Space Agency, aimed to gather temperature data and analyze the composition of lunar rocks and soils to enhance our understanding of water content variations over time. Bethany Ellman, the principal investigator for the mission at Caltech, expressed her disappointment, stating, "We're immensely disappointed that our spacecraft didn't get to the moon, but the two science instruments we developed, like the teams we brought together, are world-class. This collective knowledge and the technology developed will cross-pollinate to other projects as the planetary science community continues work to better understand the moon's water." Historically, NASA's Clementine mission in the 1990s was the first to detect water on the moon, marking a significant milestone in lunar exploration. The ongoing lunar mapping missions are crucial for identifying water sources that could support future human habitation. Looking ahead, the Artemis II mission is slated to reach the moon no earlier than April 26th. With a crewed Artemis III mission planned for mid-2027 aboard the Orion spacecraft. It's worth noting that humans have not set foot on the moon since 1972, making the upcoming missions even more significant. What are your thoughts on the challenges faced by space missions like Lunar Trailblazer? Do you believe that the risks taken in such high-stakes endeavors are justified? Share your opinions in the comments.